metering pumps in the basement, plus one transfer hose pump and 2 new tanks that are all shiny and new and ready to go. So we have 2 trainers here today. Richard Johnson from
Watson
Marlow, the pump manufacturer. Then we have Syed Hussein from CDM Cement. He'll go over the SCADA screens that are with our new pumps, and that's it.
Right.
Whenever you're ready.
All right. Morning, everybody. Sorry, right off the bat. Been dealing with allergies, so I'm having some frogs. I'm here to talk to you about the Peristaltic metering pumps. Very simple operation for those of you who aren't familiar with Peristaltic. The way it works, hold on. Is you have this tube that lays around in this track here. And as this rotates around, it has rollers here that pinches the tube off, pushes fluid through, and then the ability of this pump to hose to reconstitute itself, it opens back up, creates a vacuum, and then when the next roller comes around, it picks it up, and it's like pushing water through a straw. Very simple operation. I'm going to go ahead and switch this on. Okay, when you first turn it on, the first thing it's going to ask for you is what language you want to use. Oh yeah. You don't want to do that with the door open. Of course, we're going to choose English and acknowledge it. All right. I'll try to get it to where everybody can kind of see. And can you see okay? All righty. Your basic keypad operations, you have your start stop here. Then you have you can run your speed up and down here, which this is also used for when you're going through menus and things. You have a mode switch here where you can toggle between your manual operation, flow calibration, which I'll show you how to do when we're down there, and the analog, which is the SCADA operation. Has a few other options that you guys don't use, like dosing, things like that, but you won't be involved in that part. Very simple to work with. Okay, you got start. You can run it up and down here. You can also change directions, which yours down here are going to be running in counterclockwise for a simple reason that going in the clockwise direction, these are only capable of doing like 30 psi. If you reverse it and do it in the counterclockwise, you can get up to 60 psi. So your system down there is running right around 40. I think that we set up the pressure switch and the pressure regulator right around 40 and 45. You have a pressure switch which will shut the pump off at 40 if it reaches 40, which means you have a blockage somewhere. And if that fails, then there's a pressure relief valve that's set for 45. So if it goes over that 40, it will open up and it will put your fluid right back into the intake side. So it's just pumping in a circle. So you've got 2 fail safes in case you have a blockage downstream. Okay. The only real maintenance you have on these pumps is doing the hose replacement. Right. What will happen is if you have a tube failure within this head, this bounce right here, and every one of them has one. And what it is just a float switch. What will happen is if the tube fails, the fluid or product's going to run down here and then it's going to trip this float switch. That will shut the pump off, and then SCADA will get an indication that the pump is off and has a leak. Okay. Once you discover that, you'll come down. Each one of these pumps came with one of these. It's just a 5mm Allen wrench, and it's your saving grace on these pumps. Notice when I open this cover, you get this red indication up here. What that's saying is the pump head's open and will not run. These larger pumps like this, they don't want them to run with the door open because it'll take a finger off. Right. What you do is when the tube fails, you come in here, and of course you would have one in here, so you would have to disengage these rollers. Once you take your old one out, you put your new one in. Doesn't matter which way you go in with it. Sometimes it can be ornery. Okay. Once you have it seated in there, you'll re-engage your rollers. Okay, now it's ready to pump. You close this and then hit acknowledge up here so it clears the fault, and now it's ready to go. Now these pumps are capable of going at 265 RPM, but we limit them to 165 for the simple reason that they will eat up hoses at anything higher than that. The elements will last no time. All right. Anybody want to come up and swap this hose out just to get a feel for it? No takers, huh? Pretty simple. It's not much to them. That's about it. There's the only other thing I can show you here is should you ever have an issue with these, with the only other maintenance you could really say is you could put a little bit of thin lubricant on the outside edges mainly of these rollers, because where they don't track around the tube, they will get a little rust around the edges. Bearings are sealed, so that's nothing you have to worry about there. But should you have any kind of issues here, this whole head is replaceable. You remove this centerpiece right here, and then there's the same Allen wrench will go in here. And you can unscrew that, and it's just a collet fitting, and you can slide the center out. And then this cover's got like 4 screws where if should something fall on it, somehow it get damaged. All right. Also, when that thing gets a leak detected, it will give a signal back to SCADA. Also, there are SCADA signals going back or to let it know that it's running and at what speed. So, all right, any questions? They're pretty simple pumps, not much to them. Yes, sir.
How many hours do you expect to get out of any one?
Around 2,000 hours is what they have us tell you, because it varies so much. Because it depends so much on how much it's used, how fast it runs, what you're pumping. There's just so many variables to it that you can't really say. So what they recommend is once you have a tube failure, which there's also a place in here that monitors the time on the pump, but I'm sure they'll be doing that through SCADA also. So what you would do is when you have a tube failure, back it off 100 hours and make that your schedule hose change. That way you won't have to worry about cleaning up a mess. And if you just get it on a schedule basis, you can shut off your input and output valves, swap this hose out, and you're good to go. That way you don't have product everywhere.
We'll go through the PowerPoint, but then we already have all the changes done already. So we'll go and log into SCADA and click on everything. So basically there will be 2 graphics, one for your storage tanks in here, one for each one of them, and the transfer pumps. The eye wash, the containment, and the second screen will be for your pumps, basically. Going back from the tanks in here, from the set points, just like every other chemical system you have, you'll put the tank online or offline to enable or disable your alarms. If you enable a tank and it has a low, it will shut down the pumps just like any other system you have. So just keep that in mind. Right now they are full with water, so this is the highest level that you will see. The transfer pump is we probably have the wrong panel right now, but it will get fixed. You can't start it and stop it from SCADA anyway. You'll have to go there to operate it. The only thing that you can do at SCADA is to stop it. It just act as an e-stop, think about it that way. But you really will never be able to restart it from SCADA or start it to begin with. So the feed pumps are pretty simple, very similar to every other chemical pumps you have. We'll calculate the gallons per hour from the pump speed, and if you click on any one of them, it will open that pop-up for you. So you can start it and stop it from the push buttons. If it's a manual, you'll be able to enter your manual speed and 0 to 100%. When you put it in auto, the speed is going to become calculated in the supplemental carbon panel that you currently have the controller in, the micro C, and they are changing the algorithm basically to give us an automatic speed set point. So once you put it in auto, that manual speed will be useless. Your automatic speed will be coming from that panel. There is a couple of trends, one for the tank and the gallons, and one for the pump speed and flow. And that's as simple as it is on SCADA. That's all what has been added in there. Before we go to the live screen, anybody have questions?
What are the pump, or what are the tank sizes? First, they're both the same size, correct?
Yeah, they are,
In
I
gallons?
think right now the maximum we are able to see is 10.1 elevation and 120 diameter, so it's really,
Carbon tanks?
yeah, the carbon
I thought they
tank.
were 36 and 3,700 gallons.
I think they are bigger than that from
Oh,
what
they're
I
like almost
see.
6,000, is that what it is?
Almost 6,000, yeah, 5,900 gallons.
So is that extra 100 gallons, is that the, like, yeah.
It's probably that 0.1 difference in reading.
So you'd say maybe they're, I guess, be rated at 5,900 gallons then?
That's what it shows, basically, based on the dimensions, the radius, and the level that we are reading right now. So 5,900 gallons will be your max.
And
So-
that's by, right, so that when they're calibrated to that 10-foot level, and that would equal
10.1,
5,900.
no, 10.9, I believe.
Oh, they're
Your-
calibrated from 0 to
Your
10.9?
4 to 20 milliamp is basically a 0 to 10.9.
Okay, so actually they would go technically higher than
I
that.
think.
Because if
Do
you're
you have a place to go higher, Steve? You shouldn't be going any higher than that. You're already covering the high switch.
right, but I'm looking, and I'm looking at it from a different perspective. What is the maximum amount that we could have on
Do you
site?
have the elevation of the tank, Steve, with you?
You're limited by the overflow, the elevation.
Yeah, the overflow is about 6 inches below the high level switch.
So it's basically,
get a
are we
high-level
already
alarm, you're
overflowing
overflowing.
now?
So yeah, if you get a high level alarm, you're overflowing.
We have a
the
high
switch is
level
6
alarm
inches
right
below the
now.
overflow, I'm sorry. So you're gonna get high level alarm before you hit the overflow.
Yeah, because they are active right now. They are covered with water.
Right.
But I don't think you are overflowing right now.
No, below it, it's.
Yeah.
Where's the overflow going?
Goes into the containment area.
Can-
Just on the floor?
On the floor, yeah.
Is there gonna be a sump in there?
There's a sun.
There is gonna be a containment sump and you are gonna have a
And
containment
that's gonna
sump.
be manual, not be automatic, right?
There's no pump in it, it's
There's
just a
no
level
pump.
switch.
No pump in it.
It's just an alarm that tells you there is liquid in there. Yeah.
Is it a capacitive switch, Steve?
Yeah, it's one
I
of those
believe
containment
it's
board.
a gap switch, yeah. Alright.
So we're
Any-
still controlling the automatic
Right now, we kind of in the middle of switching, yes. So the old panel is still going the same old way.
And is it gonna be all on SCADA?
The old panel? No. No, so,
None of the
like the only,
Like I won't be able to change the nitrate set points.
you
on
will
SCADA?
still be able to see this micro C screen, and just like everything used to be, nothing is gonna change until we are ready to put supplemental carbon in the new building, basically, in the new
I'm
tanks.
asking about the end result. If I want to make a set point change when all is said and done, is it done on SCADA or on the old panel?
There is no set points as of right now being entered as SCADA except the manual.
right now, it
screen.
means like a final, like when it's
When
done.
it's all done,
Right now, you have to still go to the panel.
Right, right now you still
And
have to
like
go
when
to
it's
the
done,
panel.
when it's completed, not already.
That's
I think this
That's
is
the
the
goal.
complete.
Yeah.
So this is, we are training you on the complete thing. If something is gonna change, we have no idea if it is, but this is the complete product.
okay.
As of now, the only set point that you'll be able to enter is the manual speed of the pump when they are in manual. When they are in auto, the speed is calculated based on the set points that you enter at the old controller over there.
Is that staying where it is? Or is it getting moved near?
It's getting moved to the, basically near to where the pumps are and the tanks.
Okay.
Yeah.
So just to go over that again, so the max height that it actually can hold in there, is that the 10.9 feet?
I'll have to look at the drawings, Dennis,
Okay.
for that question. Basically, you'll have to look at the tank drawings and calculate
What are you getting
the
at?
overflow.
Well,
and all
we
that.
have to report for our tier 2 forms the maximum amount of whatever chemical it is that we could have on site. So it's sort of a documentation
So it
sort
would
of
be,
standpoint.
I mean, the most you can put in there is the base to the overflow elevation.
Yeah, right.
Yeah.
So whatever that volume is to that.
So,
Well, ideally, you really never wanna be where you are right
High-level
now.
alarm.
Yeah.
But even if you ignore the high level alarm, you can go to the overflow elevations.
Right,
What-
so that's 6 inches above the high level alarm.
and what's the high level alarm?
I would have to look at the drawings. We don't know that. All what we know is basically right now, 10.2, the alarm is active.
So you have to find the tank drawings and just look at
Yes.
the overflow
You
elevation.
need to look at the tank drawings and look at where the bottom of the tank is, the radius of the tank, and where the overflow is. That's all architecture, like drawings. I'll have no idea where they are. But as of now, this level, you should not be seeing this level under normal operation because this is a high level alarm basically. Right now, your high switches are covered with water, which should not be. So ideally, you'll never be able to fall to that 10 feet level. You should stop before it.
But the other screen showed it.
How's that?
That's that pegged,
So which one is it?
Which one is it, yeah?
current up to 59.
You said they're on 6,000.
The light screen is what you have. Those are screenshots. So right now, to access the supplemental carbon, you click on the filter building,
Oh, was it?
and you have two ranks.
Andy,
One for the carbon tanks and one for the carbon pumps. If you click on the carbon tanks, you'll get to a graphic that shows you the tank and the volume, the containment alarm, and the flow switch for the eye wash. The transfer pumps are there, but again, you can't really do anything with that transfer pump. It's an e-stop only when it gets to work. This is not functional as it stands right now. Nothing that you'll be able to operate from SCADA. The levels and the set points are accessed from here. You can put the tank online or offline. The only reason you're not getting a high alarm or a high alarm right now is because both tanks are offline. Once we put them online, those two tanks are pretty high and they will give you both the high and the high alarms. Any questions on that? And again, for the tank volume and where to fill and where to stop, you probably need to look at the drawings for that tank to show you the dimensions. All what I know is the radius is 120 inches. And if you are at 10 feet, that's what's calculating for you the 5,900 gallons. Ideally, again, you are now at the high level and the lights at the fill station are energized. So you should never be getting to that point. Any questions before we move to the pumps?
Does that say 10% or 100%?
Percent?
Is there a percent at all?
10 feet.
No, 10 feet. So 10 feet and 8,900 gallons, yeah.
It's time for classes. All right, everyone.
Alright, so going to the pumps, again, pretty simple. The 4 pumps, from any pump, right now we have pump number 1 running. They are all in remote, so you can go ahead and if I want to start pump number 2 in manual, you just hit the start button and it's running at 50% speed. If you want to adjust it to 75, it will run at the 75 and you'll be able to see the feedback in here. And the stop is basically gonna stop this pump. The pump, if your speed set point is set at 0, it will never run. It will give you a fail to run alarm. So before you try to run the pump in manual, make sure there is a speed set point in there. Okay? Now once we switch to auto, which we didn't test yet, but we are gonna do that today, that speed is no longer valid. Whatever number you'll enter in here will be of no value. The number that will be controlling the pump will be coming from the micro C panel from the controller that we have right now that's going to be moved into the new location.
So, I got a question. From what I'm seeing on this window is that you have one pump dedicated to each bioreactor, so if the pump fails, there's nothing to back it up.
I don't believe there is.
So that means you'd have to call somebody in and have it fixed?
We have
I
2
believe that's the
Shell
truth.
spare pumps on site, so it'll be not a
So yes.
cutting.
You don't want to, there's no redundancy then.
This is one of them there. It's one respect right here.
They're pretty easy to install. I mean, it's not that difficult to pump. The trends are basically where you usually access your trends from. So that's for the speed and the flow, and there will be the tank level and the gallons on the storage tank graphic. But that's pretty much all what we have new for the supplemental carbon. So, any questions? Trends eventually will come. Just takes time. This is the first time.
Once this thing gets operating, if there's things that you want to change, just write a work order. I don't know if all this stuff is in job yet, but it will be by the time we get it going. And then just write the work order for the equipment and assign it to Denise. And if you can't find the equipment, you can pick out SCADA. That's actually in there as a piece of equipment. And then just put your description in there for your wish list and we can discuss it. But everything that he set up there is based on the contract, which was, the design was done. A lot of people that weren't here when it was done, and there's a lot of people that were integral part of this design that aren't here anymore. It's just the gears of municipal work grind kind of slowly. So if this thing starts up and you want to see a change, we can work on it. Just don't throw your hands up and say this sucks and don't use it.
Yeah, I understand. One of the requests was the ability to enter NOx set point
Which I
from
think Joe was
the
getting,
SCADA.
alluding to that,
Yeah,
right?
yeah.
So once it gets going, just write a work order and assign it to Denise and
Yeah.
we'll
That means like we need to change the program, and they actually also, the vendor will need to change their program too to be able to accept that set point. But it's just not something we can do on the fly like this week.
The whole
That's
communication part of it was kind of it was an unknown sort of cloud at the beginning when we did this whole thing, because they've had to change their programming platform, I think,
Yes.
to accommodate us. So when we did this thing, we said, look, let's just move the panel over and let everybody work on it the same way they're working on it now in the pilot study, and then we'll figure it out as we go along. But they since have figured out the communication, so any changes you want, we can look into it.
Yeah. I mean, I think we're talking about the NOx set point for each pump and the maintenance mode for each pump. So we already talked to them. They are willing and able to do it. They just need a week or something to do the changes. And then, I don't know, we'll just need to work through Denise and get things scheduled and all that. But I don't know if it's gonna move forward or not. That's
Right.
really up to you guys.
I'm running late, but did you go over the purpose of the transfer pump?
The purpose of the transfer pump
Besides the
to
transfer.
basically transfer between one tank and the other.
Why is-
No, we didn't really.
You notice it's a lot larger than the pilot one. It's also up out of the containment zone. You notice that too. It's up on a big concrete stand. And we probably need Edris here, the EOSI expert, to explain it more. But those, that material has a tendency to develop kind of an organic layer on it. They call it mung, and I don't remember, that's an acronym for something. But the purpose of the transfer pump is obviously to transfer between tanks. If you want to clean a tank or get into the tank, you have a high volume pump that you can empty it into the other one if you have the room. And the other is just to move the material around on some sort of a frequency that we haven't determined yet. We'll leave that up to Edris and his EOSI guys, just to get rid of that layer.
Yeah.
It's not a contaminated layer. It's just something that has to be mixed back in.
Why didn't they put mixes in? Why didn't they put mixes in then?
It's
Well, if you go
actually
down
not
there-
just the tanks. I think it's also the pipes themselves. They get caught with that layer, thick
Do
layer. I've been to plants where they have to use hoses after hoses because the old hose gets blocked from
Is
the
there space
supplement.
between the top of the tanks and the ceiling to mount mixers then?
That's what it was. So the volume of the tanks is based on our highest consumption per day, per week, or whatever, and then the frequency of the deliveries that you could get. That's how you determine what volume you need. So if you had, if you were at your highest consumption, and you got a delivery on a Thursday, and you had a long weekend, and you couldn't get another delivery until a Tuesday. I think that's the way the whole thing is set up. So by the time we got done with, we even looked at square or rectangular tanks to fit in there because we were running out of headroom. But to Ron's point, that's why we don't have mixers. Because if you go down there and look, there's barely enough room in there to put the level in by the time we got done, and the vents and everything. We had to move a lot of conduit and piping and everything just to accommodate the height of these tanks.
And I think you can also dilute it with the plant water. That's also part of the transfer pumps equation in here, if you want to, basically, because you do have a link to insert more water in here into the cycle system. So,
You know, we even considered taking out where the caustic system is now. We considered putting the micro C system there and leaving the other caustic tanks there. But what you were doing at that point, you were crossing caustic over micro C and micro C over caustic to get to their endpoints. And the two of those together, glycerin and caustic, basically make soap. So we didn't want, you know, if you had catastrophic failure of both of them, you may end up with a big soap factory down there, which we want to avoid.
Just clean floor.
So that what's that? Clean?
Nice clean floor down there.
Yeah, so it kind of separates it. The caustic goes to the west, micro C goes to the east. That's why, and it was a lot harder to put in that case. But we eliminated that sort of consequence of failure.
So will the high level alarm turn off the transfer pump
The high level alarm will turn off the pump. Also, it has an e-stop that will turn it off. High pressure and a leak that will turn it off. As of now, we ended up with the wrong panel, I believe, for some reason.
It has the wrong starter panel on it, so
Yeah.
you can start it out there in the field manually. You can go out there and start it and transfer, but you can only stop it there.
Yeah.
And it doesn't have the leak and the high pressure detection safety on it.
So we'll have to replace it basically. It's functional locally, which is the objective of that pump. But you'll never be controlling it from SCADA, but that panel will need to get replaced.
What's the capacity of that transfer pump?
Question.
So
Don't know.
it's
We'll
a,
have to look at the.
It's a 50. Do you know the capacity of a 50 more or less? I don't know the gear ratio of this thing.
Oh, you need to,
It's bigger than these ones?
have that.
So
Your transfer pump.
Is this still accessible from that micro C on the overview screen? Did you say that?
Yeah.
Is this accessible
That's
from
part
that
of
micro C on the overview window? No.
You go into the,
Yeah, I showed them that, but I saw that, but I was wondering if you click on the micro C, you can still reach this as well. On the overview window?
No, on the micro C,
That's going
you're
away.
just reaching the old system right now, which we are gonna leave until we move the panel in there and get the system operational. So the old link for the micro C is still gonna be your path to the old system, which is still gonna remain in operation until probably Maybe 16, May 15. I don't know when that panel will get moved.
So 77 gallons a minute, so I think it was if you had a full tank and an empty tank, and you wanted to put the full tank into the empty tank to get to the full one, if there's a leak, we wanted to do it in a hurry, so you can do it in, I don't know, less than 2 hours, I think it was, or something. It's like the time between breaks, I think is what we figured out, so somebody can be watching.
This pump's only set to go full speed also.
Yeah.
Another thing on your control panel, it's gonna have a jog and reverse to aid in doing the hose changes. It's really hard to do if you don't have that, especially on the bigger pumps.
That's for the transfer pump,
Yes,
right? It
yeah.
will have a forward and a reverse.
Yep, and a jog. You have to bump the hose back and forth when you
Yes.
part of the installation.
So we'll be back to test that, and I think we have one more problem to resolve still with the pressure switches, and we'll have to see what we need to do about that, because as of now, if a high pressure switch comes on, shut down the power, kills the pump, we lose the remote contact, the pump turns off, and you have no pressure indication because the switch recovered and the pump basically shut down. But you will have no alarm that it shut down or anything like that. So
Is this running on water right now?
it is. It's running water right now. Yes.
What's the issue with the switches?
So, about the design, the pressure switch is in series with the power to the pump. So if you get a high discharge pressure, the pump shuts off, and then the pressure switch recovers immediately,
And it turns on.
and it recovers so fast that SCADA doesn't see the alarm. So all SCADA gets is a fail to run alarm.
I don't know where that. So if that switch is wired to the pump first and then to SCADA, is that the way they worked it? Or
It's two separate contacts.
How are you,
Switch.
so what are you getting for a discharge pressure right now, just for run pressure, just out of curiosity?
The highest we saw was 30, the one that's pumping the bioreactor 4.
What's the switch set at?
We set it at 40.
It's gonna be more with micro C, because of the density difference.
Originally, they were set at 80, which we saw as being way too high.
Well, it might be for water, probably not for micro C. Was the set point called for to be at 80?
They were all at 80 from the factory.
Pump's only rated for
Look,
60.
you might trip on micro C, that stuff is a lot denser. and a
The
little-
pump's only rated for 60.
But yeah, I don't think the pump will operate at 80.
Pump's only rated for
Yeah.
60.
So you should check with
Micro
Anthony
C
on this whole
January.
thing on what he wants for
Good luck
stuff,
with it.
this stuff with Junior. So they clearly shouldn't be, I mean, at 80, they're not gonna do anything, right? The pump is gonna, the hose in the pump is gonna go first.
Yeah. The pump will fail first before the pressure
So,
switch
you know, maybe
comes.
somewhere between 30 and 50, I guess.
We have them at 40 now.
They're easily adjustable, right?
Yeah.
Yeah.
We'll find out, they don't have to get micro C.
Yeah, the only issue is hopefully it's not above 60 because that's all what you have for the pump.
We can check and adjust with micro C.
Yeah. But regardless of that adjustment, we need to make another adjustment to get the pressure switch back into the SCADA system, which we are not able to right now. So we might have to do some rewiring in there to latch this switch somewhere.
Was it wired in accordance with the contract, to your knowledge?
Yeah.
No.
Do we need to get Rob involved in this, or is Steve working on this?
I don't think anybody is working on it. We discovered it afternoon yesterday, so we still need to look at how it's wired and what was in the contract, and then go back and maybe do an RFI for that.
Okay.
And do it that way. Yeah. You were gonna answer a question or have a question? Yeah.
I'm
You
wondering
want to-
about when we take deliveries, do these tanks fill simultaneously, similar to caustic? Or with the transfer pump, are we filling one and then transferring over to the other?
They have two tank
screen?
One
I
each
thought they
tank.
were two
One
separate
in each
fills.
tank.
They are
Can a
two
tank hold the
separate
whole load?
fills,
But I think you can
I hope so.
so you
Otherwise
can.
We're gonna have a mess.
cross-connect them.
It shows cross connection.
You can do what you want.
I thought you had both options.
You can really do what you want. You can fill them at the same time because there's two fills and there is a cross connection. So it's really up to you if you want to fill them both at the same time or not.
But you're not filling both, you're filling one and it's,
Correct.
Okay.
Unless your transfer pump is on, you're really filling one. So
They're probably gonna wanna do first in, first out anyway, which means to build them.
well, but if you got the transfer pump moving stuff around all the time, I don't know. Because it's not gonna transfer over to the other one by a cross connection fast at all.
I don't think that was the purpose of the transfer pump. It wasn't meant to just fill one tank from the other unless you have an emergency. The
Right.
purpose of the transfer pump is to keep that liquid moving so it doesn't accumulate over the pipe and the tank.
I'm just thinking I don't wanna, try and take a delivery and overfill a tank.
Yeah, I'd probably, if I was in your shoes, I'll do one tank at a time and fill it and make sure I don't hit the high on that tank and then go to the next one.
Hope I won't deliver.
And those fill pipes are properly labeled with like tags around them?
It should be. There is a two fill tanks, one for each pipe in there.
Or whatever, says number one, number two, or whatever on it.
Yeah. So, and there is a panel for each one of them. So each panel for each fill pipe that tells you if that tank that's connected to that fill pipe is high and you can read the level while you are sitting there outside. So you should be able to know
Oh,
if
okay.
it's getting pretty near to the high, and if it gets to the high, you'll definitely know. There is a horn and there is a light and
Yeah, I didn't even realize that there was, I guess
Yeah.
it makes sense to have the panel out there.
yeah. Now you'll see that panel when
I
you
walk
walk down
by
there.
there, but for whatever reason, I don't know.
Yeah.
And then, is this the levels on these, the gallons for the tanks, are they on any other screens? Are they on any of the like totalizer sort of screens? Like when you guys take your logs?
Not yet. We probably this is where we have them.
Like that every time? Okay.
Yeah. So this is the only way they are showing right now, but we can easily copy them to anywhere else you guys want to see them. Any other questions? All right, so well, that's it for the new carbon system. And once we add the set points, if we are gonna move ahead and add those set points in here, all what you will notice that inside this pop-up, you'll have a new set point that's called NOx set point, basically, that you'll be able to enter for each bioreactor. But that will be a change maybe in a couple weeks from now if we move forward with that.
Okay. As you can see, this is the one that he started while we were up there. It's running at about 50%. Got your input here, your output, backwards, your input here, your output here, going into the lines. This is your pressure switch. We have it set for 40 psi. And then as a backup to that, we have your pressure relief valve set for 45 psi. Where if that fails, it will bypass the fluid back into the system. All right, guys, we'll go over some of the peripherals for your pump here. What we have here, you have your pressure switch here is set for 40 psi. And then to back that up, we have a pressure relief valve that's set for 45. Where should this switch fail, this will bypass it right back into the supply side. Okay? You have a pulsation dampener, which you're not getting a lot of pulsation, so we've got that set up to deaden that down. Most of it's absorbed by these hoses anyway. Okay? Next thing I want to show you is how to do a calibration dose. Not something you really have to do on a regular basis, just maybe after you do a couple of hose changes, and all you're really doing is keeping this honest. Because it's not going to affect anything on your SCADA side or anything. It's just going to change, it's going to show on this number here. So if you're down here running it manually, you're going to know what you're doing. This screen, we can set it right now, it's set up for RPM, but it can be set to show any kind of increments you want. GPH, GPD, milliliters an hour, milliliters a minute, whatever how you want it set to tell you what is pumping. Right. The way you calibrate this is I went ahead and I filled this calibration column up. The way I did that was I closed off your supply line. Each one of these has your intake valve coming from your supply line. All I did was close that off, open this valve up for the calibration column right under here, and then you can fill it by operating this one to get this full. Now you're ready to pump out of this column. I've set it right here to 0. And it's very important whenever you're doing the calibration that you try to get this dead on and get it accurate. I need to bump it a little bit because I went a little bit high. So I'm just going to hit start and stop for a second. And that puts me dead on at the bottom of the meniscus because right there on 0. Right. What you would do then, you'll go here into your menu and you'll go to mode. Alternately, you could always just hit this mode switch. Then you toggle right down to where it says flow calibration. You hit select, then it's going to ask you at what speed you want to do it at. These pumps, we've got them regulated or topping out at 165 RPM. 50% of that is 8250. The reason I do that is that way you're right in the middle of what your speeds are. You're right in the middle of the range from 0 to 165, but you're right in the middle. So you can use these arrows to bring that speed up and down, and it's still set from where I did it yesterday. Got it set at 82.5. Once you select that, you hit enter. Then it tells you to press start. What you want to do is pump this down as far as you possibly can and keep it on the scale. Because the more you pump, the more accurate you're going to be. So for training purposes, I'm going to stop it dead on 2,000 milliliters. You read that on this side. Okay, it's telling me it needs to go more, but I'm going to bypass that. You can go ahead and accept it and go on. All right, I pumped 2,000. It thinks I pumped 18.5. So you take these arrows and you see this the bottom number is changeable. And what you do is you change that number to what you actually pumped out of that column. Alrighty. I changed that to 2,000, which is what I pumped. Then you select enter, accept, and then you go back to whatever mode you want to leave it in. You can toggle it up and you push up here and put it back in manual mode, which is where you run it from here, or you can toggle it down here to analog and put it back in control of SCADA. And I think he still has it set up for SCADA, so I'll select the analog. Now he's turned it off. When we first came down here, he still had his computer turned on and giving it a signal, but he's turned it off now. But like I said, you can go between your modes here. You got your manual, your flow calibration, your analog is the only things you'll be concerned about on your modes. Okay. So I'm going to put it back up in manual. That's where you start and stop it from here. Okay. Here's your float switch like I was telling you about. Whenever you have a hose failure, that's going to flip down and trigger, and you'll see the screen turn red, and it's telling you that you've got a tube failure. What you do is you would change your tube like I showed you. Do your tube change like I told you. Once you're all done, you hit acknowledge, and that clears that fault out, and you're ready to go again. Any questions? Okay. Should this PRV trigger, it's going to reroute back into your tank vent, and it's going to run up there and vent back into the tank. The next time you do a calibration or the next time you do a line flush, you're going to need to open this line. You'll have to get your calibration column empty and be sure it's empty, and then open this line and make sure there's no more in there, because this is your vent to your calibration column also. So you're just having to make sure that it's closed. Make sure you open it up and let that come down. And then you'll either have to pump some more out, or you'll have to add some from over here. But just be aware that this vent to your calibration column is also where your PRV vents to and takes it up to the tank. So just be aware that if you want to do a calibration, you need to make sure this line, be sure you empty this and then open this and drain that line out.